This week we talk about the internet. We're all users of the internet. We're taking this class over the internet. The objectives of this chapter will be to explain how the internet was created and give some historical perspective, describe the technology which makes it all work, and describe the web because they're two different things. Discuss the evolving tools that we use. Some people are using them in their projects, the trends that are changing it, and the social and political issues that are raised by the internet. Censorship, for example. So let's begin. The internet was started. The father of the internet is named Vince Cerf, and he's also now what the Google Internet Evangelist. And it started under a project. It was a military project called the ARPANET Advanced Research Project, and it was intended to work with the Department of Defense to be able to figure out how they could connect information from ships and cars and missiles and put all this information together, because it was back there in 1969 where they saw that this integration of information was going to be very important, A, for tracking assets, but B, for them all to be able to work efficiently. They could see how there was like a relationship between all of them. The project was disbanded in 1990, but the positive outcomes of the project are what turned into being the internet of today. The internet is simply a connection of servers. It's not owned by anyone, but it started first with linking academic institutions together. So for example, there was a project I think that Stanford was working on and MIT was working on, and there was limited funding. They each wanted to get a server because a long time ago, not being all that long, in the 1970s, for example, at universities, you didn't have a computer. You had to do what they call sharing. And as a student, when I was at the University of Wisconsin taking a computer course, I would have to wait until the wee hours of the morning where we would have a small window of our computer time available for us to do our testing of programs. So in order to be able to get more internet space through grants and things like that, the several universities decided they would share a computer. And that was the start of the internet, because you had to be able to access that single computer from multiple places. It's impossible to actually determine the size of the internet because new servers come on board all the time. Servers go down. We have billions of users, and because we have different ways of identifying users, it's really difficult. It's decentralized. There's not one central place that is controlled. There's a group of engineering groups and a group of professional organizations, and they set the standards that all of the internet the main players, which are mostly telecommunications. IBM is a big player, Cisco is a big player, the big AT&T, Verizon, all of these are big players in terms of having servers available. And so it doesn't have those hard boundaries. The internet protocol that we use, and take note, it's Transmission Control Protocol, Internet Protocol. We just call it TCP/IP. And it's an open standard. That means that all these different servers, if IBM has one, if Cisco has one, if Marymount has one, they all have to be able to read this particular standard. It's not proprietary. Cisco can't have its own standard, because the whole idea behind the internet was an open sharing of information and in connecting different types of networks and computer systems. It doesn't matter. TCP/IP, the important part is it breaks messages into packets. So a good thing we as users don't have to worry about that, because most of us, we just go on to the web, which I'll talk about in a minute, and the browser worries about that. But each piece of information is a packet, and the packet has different components to it. So an IP address, if you, go back. Okay, an IP address, as you see here, is this series of numbers separated by dots. And these all have meanings. It identifies a server, it identifies, a place, it identifies all these different components, the user number. And the importance of this is that it allows you to be able to go to the exact place it needs to be. Now, part of it is the identification of the packet, of the place it needs to go. And part of that information is the actual piece of information that you need. So each internet host computer has a unique IP address. Okay, so there's several different things. There's a dynamic address, and a dynamic address is something that you and I do when we go onto a website. We don't go to that website all the time. For example, when we sign on to our Marymount account, we get an IP address, and it's assigned to us randomly. We don't have the same number every single time we sign on. A static address is best for web servers. They have the same address. They're always on. They're always waiting. So that would be a static address. Right now, we have a standard of IP version 4, and we're moving to IP version 6. So we're actually in a transition. And the reason that's very important is because the growth of the number of users for the internet has grown, because with each device, so think about the number of devices you have. I have a phone. I have this computer in my office. I have a laptop. My Blu-ray player has an IP address. I have a smart TV. I might have a smart thermostat at home. All these things have IP addresses. And so as the number of devices increases that allow us to be able to interact through the internet, the number of IP addresses has to grow. And right now, we are actually running out of IP addresses with IP version 4, so thus we are moving to IP version 6. Okay, so inside the internet, we have something called a domain name. And what that translates to is it's kind of like when we go to a particular website, so now we're talking a website, it has, different levels of domains. And we know we can identify what type, we can often identify what type of server we're going to by the last 3 letters of the domain name. So, for example, each domain name, for example, has to be unique. So, for example, I have a domain name of susanconrad.com. Nobody else can have that domain name. They could have susanconrad.org, they could have susanconrad.biz, but they can't have susanconrad.com because that is my unique domain name. So these are just some of them. One important thing about this one, edu, you don't have to have something that's sanctioned as an official educational site to have an edu site. So be cautious of those. Okay. And when you're setting up a domain, you can actually pick what you want it to be. So there's nothing that really limits it, except think gov. You can't pick gov. And even edu, I think you do have to have some criteria, but not that much. So for example, here's an example of somebody. This is Kelly, and she's at this CS, the host network, ALAR, the domain name for Aliar State University's LAN. So, and it's an education. So for example, sconrad at marymount.edu is my name, sconrad at marymount, that is the server.edu, the type of organization. Okay, so internet access options. We all know about these. Many of you are too young to remember that there used to be dial-up phones. Most recently, when I was overseas, even though it was broadband, it was as slow as dial-up. So it did make me think about how you design websites for a worldwide population. But there's 4 types. There's the DSL, standard phone lines, the cable modems, which are much faster. And DSL actually, there's different levels of DSL, and I don't think they're talking about dial-up here. Satellite dishes, and then high-speed radio waves. We primarily use these. These are the types that we use. Internet service providers, so if you think about those, Cox is one, Comcast is another one, Verizon is a third. So those are the things. And online services, extra services such as news, chats. Okay, now internet servers. So internet servers, like I said, the internet is nothing more than a connection of servers from all over the globe. Okay, it's just a connection of servers with connectivity utilizing TCP/IP as the protocol to connect them. And an internet server can have all of the following things. It could have an email server, which is different. It could have a file server, which just keeps files. A Dropbox is sort of a file server. All it does is keep files. An application server. So for example, Adobe Online. You can do Adobe programs online. That's an application server. There's other ones. WordPress is an application server. And web servers. Web servers like sending web pages. So that would be like you're shopping at Amazon. It's a web server, right? Okay. So web protocols and web publishing. The URL. Okay, so we all know what a URL is. The URL is here. It's the HTTP votesmart.org. You know, this is the URL. This is the address that we go to the internet server to get the information. And in order to be able to get the information, because the information is written in a language called HTML, hypertext language. And that language was actually created in the 1980s by Tim Byrnes, and he put this together because he wanted to be able to have documents shared between different universities. So it started out as just a way to be able to share research documents between universities because they wanted to download each other's papers. Now you can see it's come a long way since then. And HTML, if you ever would go to a page and click View Page as Source with your right mouse button, you would see this HTML code. And it includes the source documents, you know, it includes the file names, it includes all of the different things, and it's the formatting, and it's actually very tedious. So luckily, there are higher level programs that can help us develop that. Okay, so a website can contain tables, frames, forms, animations, search engines, all of these things, pictures, YouTubes, streaming audio and video. You know, all of these things put together create what we call a mashup, because it's taking all different types of medium and mashing them together into a single format that we can view within one screen. Okay, so then there's plugins too. And we all know Apple's QuickTime for looking at multimedia, because in order for all of these different formats to work, we have to have some type of program to be able to take that media and be able to present it to us on the screen. And if you think about what's really happening behind the scenes, it's pretty amazing. Okay, and we all know about things like cookies we go to a site, they get our IP address, and that cookie stays within our browsers. You've got to clear those cookies out, otherwise you're on a list. It's a way for the people, the website, to be able to track its users. Okay, and a content management system. Our LMS, for example, Canvas, Blackboard, are a content management system. They allow us to keep information, and it doesn't require updating of the HTML code, at least not to us. All right, a couple of other things. You can read about these. These are all different kind of programming tools. The one I wanted to bring up was Ajax. And what I find most interesting is Ajax has really made a difference for shopping. So for example, when you go to a site and then you change just one little item, like you go into your cart and you just change one item in the cart, you know, you don't have to redo the entire shopping cart again. It just allows you to make that one change. And that's really because of this Ajax, which is this asynchronous JavaScript languaging. So that made a huge difference. All right, so here we have some other things. Search engines we all know about. Yahoo, we all know about Google. Spiders, I think, are really interesting. They're software robots that explore the web and retrieve information. And our search engines use that technology to be able to find things. Boolean logic, which is something we can just say in natural language. We're doing a query, we want to say something to the effect of find houses built in 1960 in Fairfax County. And you could just write that in your search engine and you'll be able to get a list of houses that would meet that criteria. So it's just, Boolean language allows us to refine what we do. We use it all the time when we're doing if-then programming. Building a website, that's a whole nother opportunity. You know, what you can do, make a plan, prepare. Some of our students in the class will be making one, so we'll be able to look at theirs. And then this is this whole bit about building the website. Keep it simple, keep it consistent, keep it small, keep it honest. Okay, think as a publisher, test before you think. Okay, all that seems very intuitive. Okay, portals. The web portal, we already know about the web portal. We can go through Google. That's a very popular way to go to the, and corporate portals. We have a Marymount portal that we use to be able to get at things. When I worked for Siemens, we would sign into the Siemens portal because within the portal there was an intranet as well as access to the internet. And the intranet was just information that was pertaining to only the people that could get into the Siemens website. So usually we would use some kind of a VPN, which would be a code on a token that we would have to enter that would allow us then to be able to access the Siemens web server, and there we would have access to Siemens specific information. Portals. Push and pull technology. I think that's a really important component. We're seeing more push technology where organizations are able to push information to us. We might sign up for it through an RSS type of feed, but if you notice now when you go to a site, that site gets your information and it continually pushes information to you. Sometimes it's very annoying. Anyhow, Web 2.0 blogs, forums, and this is what I talked about before, mashups. Creating a podcast, you can read this more on your own. And a couple of different things here. So one of the things about the internet that's important is we in the U.S. have a lot of freedom as to what we put online. But that's not the case in all places. For example, in China, they don't allow Facebook. They limit what you can see. So other countries have their own restrictions as to what they allow you to be able to access. And that is a form of censorship. And Iran, they have limited access to many of the different sites within the internet. So, and if you go to certain sites, you get on a list. So we don't have that. We say that pornography is one of the sites, children's pornography. If you go to sites that have children's pornography or you engage in that activity, that's an area where we say that's a crime. So we too have our own ethical choices as to what we feel is right about internet. The digital divide, we here in this country, we do not realize how much access we have to the internet, how fast it is, comparatively speaking. When I was over in China, for example, I was unable to download a PowerPoint and then reload it. No matter what I did, it just was, my bandwidth was not sufficient enough within the hotel to be able to do that. And in a 5-star hotel in the U.S., that would never be a problem. So we forget that we have such great access in this country. Okay, net neutrality. Should it be free from restrictions? So, for example, right now, a lot of the web is being fronted by telecommunications companies, big server companies, big technology companies. All of these organizations, they front this equipment. And should they in their own way start to put little restrictions? They start to do things to lure you over to the sites that they sponsor, or they are more, they get more profits from. Let's put it that way. And how do we protect that net neutrality? How do we prevent telecommunications companies from having too much say as to access, too much say as to cost? That's I think a huge issue. And then cyberspace, the shared virtual reality. We're really moving into more of a virtual augmented reality. The term virtual reality I think is overused. Virtual reality is really putting a situation in a virtual space and then simulating what it would be like in that virtual space. Like if we were to pretend we were going to another planet, we would have the capabilities of whatever that other planet would be, and then we would test what that's like. So the internet is changing radically. We're going to talk a little bit about the internet ambience, the ability for digital ambience, for the computer to be able to really sense people and sense situations where they can make decisions, a form of artificial intelligence. So that's going to be coming. So, okay, so the internet is a network of networks. The web is a part of the internet, but it is not, the web and the internet are not the same thing. So that is it. I hope you've enjoyed this presentation, and I look forward to any comments you might have.